Okay. So the basic idea was dealing with refraction. Here it represents a ray of light coming into my prism. What's going to happen as this ray of light hits the surface? It's going to refract. What does it mean that it's going to refract?
It's going to bend.
It's going to bend. And as it goes from the air into this glass, how is it going to bend?
It's going to bend inward, like
towards the normal of this. Let me go ahead and write up. I'm going to use an N of 1.7 on this situation. Okay, so to figure out how it's going to bend, it might be helpful to figure out what the normal is. Okay, the normal is the thing that's perpendicular. I've got this protractor. If I lay it up here, right at that spot, then that's going to be the 90 degrees from the surface. That's the perpendicular. So I could draw my normal through here.
I can't see you.
And so what we're going to do is we're going to measure the angle. And we always measure from the perpendicular. Snell's law doesn't work quite right if we measure from this. So I'm going to take my protractor, I'm going to put it up here, line the center of the protractor right up with that spot on there, and okay, so this is 90. I don't want to just read off of this because that's going to measure from the surface. I want to measure the angle from here, and so that's 90. That's 10 degrees, 20 degrees, and a little bit more. That's 25, probably about 22. So we'll call this a 22-degree angle. Okay? Now, what are we going to do with this? Well, there's a relationship that's been experimentally determined that we can find the angle that comes in using Snell's law. One way of writing that is N on one side, the index of refraction on one side, times the sine of the angle on the same side is the index of refraction on the other side, the sine of the angle on the other side. One side equals the other side. This side equals that side. Well, if I'm out in here in air, the index of refraction in air is basically what?
1.
Basically 1. Very small, greater than 1. So that's going to be the sine of 21 times the sine of 22 degrees. Here I'm in this glass. I've told us that the index of refraction in this glass is 1.7 sine of this other angle, which is now not known yet. Okay. So what do I need to do next? Well, probably need to get out a calculator and plug in 22 and get the sine of that.
0.375.
0.375
375
is equal to 1.7 times the sine of my angle. Well, to get this by itself and solve that, I need to divide both sides by 1.7. And so I'm going to get the sine of my angle 2 is equal to 0.375 divided by 1.7.
You'll get 0.22.
0.22. Sorry, that's getting a little close there. And then if I take 0.22 and take the inverse sine by hitting the second function or the inverse function on the calculator and then the sine function, I'll get what my angle is equal to a certain value.
12.73. 12.7.
12.7. Now that I've got that, I can come back and say that means that this angle is going to be 12.7 from here. Now, it's not going to go here and bounce like this. Light doesn't do that. It's bending. It's not bouncing off of this imaginary line. It's going to be over on this side, something like that. To find out exactly, I need to put my protractor up here. Okay, so 12.7, end up here. That's 10, that's 15, so those 12.7 is going to be right about between those two. And that means that now my light ray is going to travel like that inside the prism. Now what happens? We need another interface, don't we? Well, the same thing, and as it passes through this interface, through this surface, once again, light's going to bend. But this time, it's going to bend in what direction? Away from the perpendicular. So we want to figure out what that perpendicular is. Let me lay this up here. First, let me get the cap off this marker. And now I can mark the perpendicular to this surface. Okay, once again, it's the perpendicular that hits where the light ray is going. I found the 90 degrees away from this, and so I can mark that perpendicular. The light ray is going to come in here, and it's going to bend away from that perpendicular. And how much is it going to bend away? Well, we've got to do the same process. We need to measure an angle and figure that out. So I come in here, put my protractor down. Here's my 90 degrees. I come out 10, 20, 30. That looks like it's right at 30 degrees. Go ahead and mark up here that we found that this was a 12.7 degree angle. And now, we do the same thing with Snell's law. So now I am in the material, so my initial angle, index of refraction is 1.7 times the sine of 30 degrees. And that's going to be the index of refraction of 1 times the sine of my second. So we need to do the math. 1.7 times the sine of 30 degrees, which I happen to know is 1/2. It's one of those things that I've done this enough.
0.85. The end result would be 0.85.
0.85 is equal to 1 sine of this thing. Well, 1 times the sine is just the sine. So I take the inverse sine of this by hitting the second function or the inverse button on the calculator and then the sine function. That's going to give me an angle that's probably quite large.
I got 58.2.
58.2. So where's that going to be? It's going to be somewhere over here. Lay this down. That's along my perpendicular. I'm going to measure from the perpendicular. 10, 20, 30, 40, 50, 55, 58 is going to be somewhere about there. And that's how the light would be refracted from there. Okay, any questions?
It's all clear in there.
Thank you.